Hey there, in this video we're going to make our first two-dimensional graph where I'm plotting what looks a lot like an image, and I'm going to use a function out of Matplotlib called imshow, which I imagine stands for image show. First thing I want to do is make the 2D data I'm going to plot. So the version I'm going to show you here for making data is not a good way to do it in general. It's a very brute force sort of way to do it. What I'm going to do is I'm going to make some empty data. So I'm going to make an empty array, and I'm going to make it 100 by 100. And just plotting a bunch of zeros would be really boring. So what I'm going to do is I'm going to use for loops to step through this array and change for every x value and every y value what's in there. This is a bad way to change arrays because it's really slow. I have to do 100 times 100 steps to get through this using Python for loop. In a follow-up video, in a few videos, I'll show you a much faster way to generate two-dimensional data. But for now, we'll do just sort of this brute force approach because the focus is not the data, but how we represent it. So I'm going to do for I in range 100, for j in range 100. So for every one of these i's, it's going to do 100 j's. That's a total of 10,000 times. It's going to have to step through to visit all 10,000 elements in this array. And then what I'm going to do is I'm just going to set the data at data ij equal to just some made-up function here. Let's just do something real simple. Let's do I minus 50 plus j minus 50. Parentheses are excessive here, but it just makes it easier for me to read it as a human. And then just to get it a quick representation of what that is, I'm going to print the array. Oh, it's getting yelled at me. Has no... Oh, it's supposed to say zeros, not zero. Not bad. Okay, so here's a truncated version of the output. By default, if you try to print too much stuff with NumPy, it cuts out the middle. So it gives us an idea that we've got the most negative in the top left, the most positive in the bottom right, and then zeros here along, or almost along, the diagonal. So now let's try and show this with a graph. And so the function we're going to use here is imshow. We're going to give it the two-dimensional array I want to show, and then we'll call plot.show so that we can see it. And so there we go. We're going to have basically banded data here, where presumably this color represents about 0, this dark blue here represents about negative 100, and then this kind of yellow is going to be positive 100. Now, just looking at this without having printed the underlying data, how would I know what value is what color? I don't have any scale on this. And so the solution here is to add a function called colorBar. Kind of like you could add a legend to a regular plot, you can add a color bar to an imshow or any kind of two-dimensional plot. And what it'll do is to the right, it's going to draw a scale for us. And it's going to show us that this dark blue corresponds to negative 100, zeros is kind of blue-green, and then up here, not quite 100. As you can see, we didn't actually get to 100, so this most yellow color is 98. Now, this is your default color scale, this blue to yellow. There are other color scales, and I'll have a link below this video to the documentation that shows you what all of the different color options are. To change that, you use this argument here, CMap, stands for color map, and I'm going to use seismic. I don't know if I have a strong opinion about what the best color map is, but the nice thing about seismic is it really emphasizes the difference between positives, negatives, and zero. So using the seismic color map, it's the same data, but the representation here shows me the negative values in blue, 0 here in white, and the positive values in red. I mean, at least that's the case if our data is just as much negative as it is positive. Really, whatever our data is, it's going to make the smallest value blue, the middle value white, and the biggest value red. So where you have this equal split around 0, seismic's a nice color map. In other cases, your data is all positive, in which case seismic is not a good choice because it visually makes it look like there's a difference right around the midpoint. So that's why there are different choices for color maps. Depending on what you're trying to represent, different colors sort of lead your audience to think different things, and you really don't want to be misleading with your color map. Okay, so great. Now let's look at a potential problem here. Let's take the array of data that we have and let's just change one value in it. I'm going to add a value of 10,000 up here at the top left corner. Instead of being negative 100, instead it's going to be 10,000. Seems like a pretty tiny change. Now let's look at what happens when I plot that. So we can see, well, the whole thing has turned this really dark blue. So why is that? Well, there's a single pixel, I don't even know if it's going to show up in the video, up here, that's 10,000, it's a dark red, and then everything else, every other pixel, compared to 10,000 is almost 0. And so everything else is getting squished into this single color. Okay, so that can be a problem for us if we have an extreme value or a few extreme values in our data. So what I'm going to show you now is how can we plot a range. So like I only really want to see values between -100 and +100. So how can I make that happen? The solution here is to add another 2 arguments, vmin and vmax. So I think probably standing for value min and value max. So the minimum value I want to be able to see is -100, and the max value is going to be 100. So now we've got scaling just like we had before. In fact, we fixed that issue where up here we didn't have 100 at the top of our color bar because our biggest data point was 98. Now we can put 100. We can control basically what range do I want to use for my color bar, and then it'll color those colors for us. And what it'll do for like this 1 pixel up here, that's 10,000, is it just makes it the biggest value it's allowed. So it'll make it dark red. So this kind of means 100 and up, and this darkest color means -100 and down. So now there's another possible issue here, 2 related issues, and that's what do we want to do with our axes here. One thing you might notice is that the x-axis goes 0 up to 100, and that just corresponds to how many points were in my array. Same sort of thing with my y-axis, how many points were in my array. But I don't really have a good way to set what x values or y values there are just looking at this. If I use xlim and ylim, like I would for a regular plot, what it's going to do is it's going to cut off our range. So if I said I want my xlim to be 0 to 10, it would just cut off the x-axis over here between 0 and 20. Another thing you might notice is the 0 for the y-axis is up at the top, which is kind of like upside down from what you would normally want. What we're doing is we're just plotting indices out of an array. Come up here to our original array. This value up here is at index 0, 0. And it's in the top left corner. And if you print that array, so same thing's happening down here. It's putting 0, 0 in the top left corner. Normally, we want our y values to have the 0 at the bottom. Okay, so our fix to these things is we're going to use a few more arguments. First, let's turn that y-axis around to make it the normal sort of way. What we're going to do is we're going to change the origin of our plot. We give this a string, lower. So by default it tries to do upper. We're going to put it lower, which is normally what you'd expect if you're printing something where these are x values and y values. The other command we're going to put in here is extent. This is a tuple of values that set what the xmin, xmax, ymin, and ymax are. So they're in that order. Let's say I want the minimum x value to be -4, the maximum x value to be 4, minimum y value to be -3, and the max value to be 3. And I'm just using different values just so it's a little bit more clear when they show up on the graph. So now if I regenerate my plot, we can see it's changed the labels. It hasn't changed the underlying data. It changed the labels. You may notice that the diagonal white here has flipped over the other way because we've put the origin in the bottom left corner. That's not just a labeling change. That's how is the data going to be drawn on the screen change. So if this was, sometimes you want this to be the top left corner if your array is supposed to be a literal image. But if your array is supposed to be x coordinates and y coordinates, so like this 0, 0 represents the value at x equals 0, y equals 0, then you want to do origin equals lower to flip it around and put that 0, 0 value down in the bottom left corner, which is what you're normally used to when you draw a graph. Let's look at what happens if we, instead of using extent, or in addition to using extent, set, say, the x limits explicitly. So just like with plots, you can have x labels, y labels, titles, legends, all that stuff is still legal here. In fact, you can even draw a plot on top of an imshow. All the commands are pretty interchangeable like that. So xlim is a legal command. Let's say I want to set the x limit to -1, +1. Let's see what that does. What's going to happen is it slices off the left hand and the right hand part of this graph, and we're left with just this part around the middle of the graph, -1 to 1. So this isn't changing how the array is drawn, it's changing how much of it we get to see once the graph is finished. So x limit is not quite the same thing as extent. Extent is saying what is the actual extent of my array. Xlim says how much of the array do I want to be able to see. So in this video we saw how to use imshow. It's our way to draw 2-dimensional arrays onto the screen. We saw some of the more important arguments to it, how to change the color map, how to change the scaling on that color map with vmin and vmax, and then how to control where the origin is drawn and what the labels are going to be on the x-axis and the y-axis by using the extent keyword.